Alright, so we're going to look at how we can add a few more little features to our calculator, and then we're going to look at how we can take it offline and make it available if you don't have an internet connection. So the first thing we're going to do is, what if we wanted to be able to press a key, like be able to press the 8 on our keypad and it enter up here. What if we want this to be basically keyboard friendly? So the first thing we're going to do is we need an event listener, and so we're going to say of course it's going to be a .on, and we're going to have an event listener of key press, and of course we're going to have our function that does something when that executes, and we're going to attach this to the document, since we don't actually have any particular element that we want to be focused in when we're listening for it. We just say anytime we're focused on this document over here, whenever I push a key, I want something to happen. Alright, so we're going to find something interesting happen. So we can listen for an event in our function. And so if we want to know what key's been pressed, we can use event.which. But that's going to return something different than what we expect. If I push the number 8 on a keyboard, event.which is not going to return 8. So let's actually alert this out so we can see what it is going to return. So now when I'm over here, anytime, let's say I push the letter 8, and I see for some reason it's giving me 56. So what 56 is that's actually a key code, and that's mapped to a particular location on your keyboard, not a particular value. Okay, it's not going to return 8. And so in order to get it, we need to basically map what each key code is to the number or the sign that we want to be listening for. So the one way we can do that is by creating an object. So we could say key codes, and we said we create an object by using the curly braces, and then inside that object we can create key value pairs for each property. So I could say 56 is 8, and we actually know that these particular ones are sequential, so I could say 55 is 7. If I wasn't sure what these were, then I could just keep pressing keys over here and use my alert function to figure out what they are. Or you can look them up online. There's some references online that will give you what each one of these are. So I'm going to say 53 is 5. I'm just backing up here a little bit. 52 is 4. Go ahead and add these here. Okay, so we can keep on going here. We can say 57 is 9, and 58 is 0. Then I also want to be listening for the plus, minus, divide, and multiply signs. And so without testing them out, I know that those are 43 equals plus. I've tested these ahead of time. And 45 is minus. And 47 is the divided. So 42 is the multiply symbol, and 46 is the period, or as we're going to use it, is the decimal point. So that maps all these keys out. So we're going to say whenever one of those is pushed, we want it to enter the value up here. So we're going to need to do something with event.which in order to find and the key codes object and kind of pair those together to see if we can find them. So we know that it's going to need to go to dot calculation. We're going to append whatever value we have there. So we could say, create a variable and say, let's call that key value. And we can set that equal to key codes. And you remember we can use the square brackets to reference a property of key code. And so we can say we want the one that has a value of event.which. Okay, so what we're doing is we're saying whenever something is pressed, let's say that, you know, we were typing 8, this is going to be 56. So we're looking for key codes 56. So key value is then going to be equal to the value of key codes 56, which is 8. So we could come in here and say key value is what we want to append. And so we're basically just using this object to map the characters to the values we want to use. So let's give it a try here. We're focused in here. And we've got some sort of problem here. Possibly a typo. Would help if I type them right. Alright, let's try it again. So now when I push 8, 9, 5, 4, we get everything that we expect. If I push the plus symbol, minus, times, divide, we can see everything works. Alright, so now we've got it listening for that, but we kind of want to say when I hit enter, I want it to, you know, actually calculate. So I want that to be equal to the equals button. So we could come in here and say if event.which equals, and I know that the enter key is 13, so I'm going to say if it equals 13, then I want to do one thing, otherwise I want to do this, append it to the calculation. So what do I want to do here? I want to basically do the exact same thing as I'm using on the equals button, which is useful because I created a separate function up here called calculate that runs whenever the equals button is clicked. So I can execute that same function down here and save myself duplicate code. So I just say calculate. And then if I hit enter, it's going to do the same thing as before. So let's say that I want to do, and I'm not focusing here, 56 plus 5, and if I hit enter, then it's going to do my calculation for me. Fairly straightforward and simple. We're just using some simple logic and then mapping some items to a property or to an object, and that's all it takes. So now we're going to start looking at offline stuff, and all I really want to do right off the bat is detect whether or not we are online or whether we're offline. And the easiest way to do that is to say if navigator dot online. Else, so we can execute something specific if it is online and do something else if it's not online. So what we're going to do is actually, let's create a div over here, and we'll say div class equals status, and we're going to say by default it is offline. And then we're going to use some CSS, and let's say that dot status, scroll it up a little bit, is, and we want to say, let's just say background color is red, color is white, so that's the font color. Let's put some padding around it as 10 pixels. And let's float it to the right. So now we see by default, before any JavaScript is running, we've got this regular, it's offline. Then we want to say if navigator online, let's change it somehow. And so we can come in here and say dot, if it's online, dot status, add class, let's just say online. Okay, so that class is going to be added only if we are actually online, if the navigator.online returns true. So we can come down and say dot status dot online has a background color of, let's just say green. But we also want to do something else. We know it's going to turn green, so it's kind of like a success message, but we also want to change the text. And so we said in jQuery that you can actually string methods together. So we're going to say online. So now if I run with JS, since we are connected online, we get a status saying that we are online. Alright, so now that we have done that, we're going to switch over and look at this same project, except it's going to be installed on a server, because I want to demonstrate how to set up an offline cache. And the way we do that is by declaring a manifest file. So you'll see this project, it's the same as what we've been working on. We've included jQuery at the bottom, we've included our own custom script.js, which has all the code that we've been working on thus far. And at the top we declared a style sheet that has all the styles that we've worked on thus far. So this is identical for all intents and purposes to our current project that we just finished working with. Except you'll notice that in the HTML here we've declared a new attribute that points to a file called cache.manifest. So let's pull up cache.manifest. And you'll see that it's a fairly simple file, and has a few caveats that we need to know about. But basically this is a list that tells the browser, or tells any modern browser, that when you go to this page and we're online, store these files and make them available if we're offline. So this is going to say the first time I go to it, I've got an internet connection, and it reads this cache manifest file and says, okay, store index.html, style.css, script.js, and the jQuery.min.js, and keep those around so that if I come back and I'm offline, any references to these files are still going to get loaded. And it's just that simple. You can see it always has to start with cache manifest, like that, and then we list out each file on a separate line. You'll notice that this starts with a £sign up here, and this is just a comment, kind of letting me know I'm using it to tell me what date it's been edited on, things like that. But it's also useful because the cache.manifest has one thing that's important to know, which is that if we're using a cache manifest file and we say let's store these 4 files, then the next time I come back to them, they're still going to use the local files. It's not going to go online and download the new ones, even if you are connected to the internet. So we need some way to be able to tell the browser that their new files exist and that we need to use those. And so what we use is anytime the cache.manifest file has changed, any character in it has changed, anything is different about it, then it'll get re-downloaded, and then the browser will use the new files. So the easiest way, if we know that we've made changes to these files but we're not actually changing what files are, we haven't changed the file names, is just to change our comment up a little bit. So I could just change it up like that, and then from then on the browser is going to see that it's changed in some way, and it's going to break that cache and download the new files if there's an online connection. And so that's a useful way for us to be able to make changes and still get the browser to download the new changes. Okay, so let's look at this. As you can see, same as what we've had before. And you can see it's got a little online down here. So let's actually disable the internet connection. It says we're disconnected. And so when I refresh it, you can see we have no internet connection, but it still loads and still works. I can still run calculations because all these calculations are running in JavaScript. We've downloaded the files for jQuery. We've downloaded our own stuff. jQuery or JavaScript runs in the browser, and so it doesn't need an internet connection in order to make these things happen. So we can have apps that work only locally, that if they don't need to talk to a server or anything like that, then we can make them available offline for people. Especially this is useful if someone's on their phone and they need something that doesn't need to talk to a server, for instance a calculator, and they don't you don't want to break this web app or make them find something else to use whenever they're offline. You can just say, okay, this is going to work no matter what, anywhere. Okay, so let's go back here and look at this. One thing to note is that not all servers recognize the .manifest file type, and so sometimes we can go into the server configuration file, or basically is what it is. It's called .htaccess, and we can, I guess I need to enable internet before I can download that. And we need to add a type, and this is just saying, okay, here is a file name, .manifest, and this is the type of file that it is, and that just tells the server how to deal with it, how to send it, and tells the browser a little bit on how to use it. So that's useful. Since manifest is a little bit of a newer file type, it's useful to have that in there just to be sure that it works as we expect. So let's jump back here to our JS bin, and let's look at something else. We talked about local storage in the last class period, and I gave you an article to read that mentioned an alternative to local storage, which is called cookies. And cookies have been around a little bit longer, and they're sort of the backbone of local storage on the internet. And it has a few downsides and a few positives. The article tells us that cookies can only store 4 kilobytes of information, whereas local storage can store 5 megabytes. And also that for every page request on a server, the cookies are sent back and forth twice on each connection. And so it can kind of slow our websites down a little bit to use cookies. Sometimes it's necessary, but sometimes we just want to store some information, for that person, for that browser, and we don't need to send it back to the server. So, but let's look at cookies and see how we can use them and kind of how they work. So in our browser, we have, just like local storage, we had a built-in object for it. We also have a document.cookie that we can use to create new cookies. Now the .cookie is very unique, and it doesn't work like normal objects do. We can assign a value to it, and it actually is a very specific string. It has to be formatted just right to specify a new cookie or to redefine an old cookie. And so instead of it actually overriding everything, it actually looks at that string and says, if it's referring to a old cookie, then it replaces that information for the old cookie, and if it's referring to a new one, then it'll append it, and it makes that decision on its own. So let's look at the format that it needs for a cookie, and we say it's basically going to be a string, and let's say we want to set a cookie called test. So we say test equals, and then whatever value we wanted it to be. Let's say it was Andrew, colon, and then we say it expires, and cookies have expiration dates, and so we need to be able to tell it a very specific date in the future when we want it to expire. We want this information to be good until that date, and we'll look at how to format that. There's a little bit easier way we can let JavaScript do the formatting for us on that. So let's leave a space for that, another colon, and then we need to declare a path, and the path means on the server or on our website what part of the website we want it to be specific to. So if we wanted this cookie to only be available to pages that were in a folder called test, then we could do something like that. if we want it to be available to everything on a server, then we can just use the root path, which is the /, and we say that this cookie is available to anything on this domain. Okay, so we've said this. And so the question is, how do we set a date on here? And JavaScript has a built-in date object that we can make use of. And we could say, we'll say expiration date, xdate, equals, and we'll say new date. And then we want to specify when it expires. And so we can use two functions called setDate and getDate. Okay, these are two methods of the date object. And so since we said the date object is referred to by the xDate variable, then we say xDate.setDate, xDate.getDate. And so these two are just methods off of the date object. So getDate is going to return the current day unless we've specified anything in here, which we're not going to. It's going to get the current date. Okay, so, and then I could say, okay, let's, if that's today, I want to add on to it a variable called expires. And we could say expires, we want it to expire in 5 days. So we're going to say down here xDate plus expires, and so that says we're going to have a date that is 5 days in the future. Okay, and what we can do is actually put that inside of our set date, and so that we're actually changing the date using set date to 5 days in the future. So now xDate equals a date, has information about a date 5 days in the future. And then down here we need a very specific string, and JavaScript helps us out with another method called .gmt string. And that's just returning a string that is formatted in a very specific way, and we'll look at what it looks like in just a second. Let's go ahead and that should work for us. So let's run with JS, and then let's inspect element on that page. And so we can, let me see if I can remember here. So now you see here that this is sort of showing us the cookies that are currently set for this website. And you'll see it has a cookie with a name of test, a value of Andrew. So hey, that's ours. We just created that. And it's got a path of this. And let's see if I can slide these over so we can see the expire date. So this is the GMT string. It has to have this format. And so that's what we were doing with the date object, is going ahead and saying, instead of trying to write all this out ourselves programmatically, let's just use the date object to return this particular string for us. Okay, so that's all we're doing. We stored our value here. You can see there's some other values. JSBin sets one particular value. These are tracking, like say Google Analytics or something like that. And of course there's a CP probe one there. And so those are all just different information that's being associated with this browser for the programmer to use. Now let's say that I don't really want to have to type all this out every time. Okay, I want to kind of automate some of this. So what we can do is wrap it in a function. And this is what I usually do. We'll say set cookie. We'll wrap it around this code. And then I'm going to pass in 3 arguments. I'm going to say I want to know the name, the value, and expires. Okay, so that's going to replace this functionality because we're going to get expires from the argument now. And then we can go down here and say name plus, and we just append these into the string. So it's going to be value plus So now, go ahead and hide this. So now these are part of, I'll put it on another line. Whenever I call setCookie, so if I want to do the same thing as before, all I've got to do now is say setCookie test Andrew and 5, and I've created a cookie without having to remember all the specifics of it. So that can come in handy. And we can also create a function called GetCookie, because that can be kind of convoluted to retrieve the information as well. So let's say GetCookie, and all I've got to do here is say here's a name of a cookie I want, and I want you to retrieve the information on that. So this can be a little more complicated, but we're basically going to, let's create a variable called cStart, and this is the we're looking for that particular name. So we're going to do that by saying equals document.cookie, and then we're going to use a built-in JavaScript method called index of, and this is basically a sort of a search function. So I can say, okay, name equals, and so that is, we're saying, okay, cStart's going to equal the index of that particular string, whatever that's going to be. Oops, should have been an equal sign. And so it's searching for it, and it's going to return if it finds it. So we're going to say if cStart does not equal -1, which is saying if it actually did find something, then we want it to do something inside of that, okay? Because it's going to return the index of where that particular thing is. Because if you remember when we said whenever we have a string, each letter has an index. So like say in this string, let's say that the period has an index of 0, the C has an index of 1, A has an index of 2, and on, just as if it was an array. And so when it's searching for index of, it's trying to get the number of the character in that cookie string, and if it exists, then it's going to obviously have an index of 0 or greater, and if not, we're going to see that it has an index of -1. So we're saying if cStart does not equal -1, that means we found our cookie. One actually exists that we're looking for. And then we come in and we say cStart plus name.length plus 1. So that's taking into account that we start by counting from 0. So we're saying we're going to get the length of that name, which is our parameter that we sent in here. So if we were looking for a cookie with the name of test, like for instance, let's say we were searching for the value of this one, then I could say this is essentially going to be equivalent to name.length is going to be 4 plus 1, and so it's going to grab that entire thing, and so it's going to return the index of the character immediately after test equals, okay, because remember it's creating this string up here, and so it's saying I want to get the index of this character that comes after the equal sign, and so that's why we've got plus 1. And then we're going to declare a new variable called cEnd, and it's going to look for .cookie.index of a semicolon. And what that's doing is we're actually going to pass a second parameter in the index of C start. And so it's saying start looking in the .cookie string starting from this index on, right? So we know that it's looking starting at the character after the equal sign. It's going to keep looking until it finds the semicolon. And it's going to return the index of that semicolon. So all we've done at that point is we have the index of the starting character in our value and the ending character of our value. And so we can use that by doing an if statement. And we're going to say if cn does not equal -1. So if for some reason our cookie string was malformed, it would return in, we're not going to screw anything up. And if it doesn't, then we want to say cend equals document dot cookie dot length. I'm sorry, I mistyped this. I'm going to say if it does equal -1. So what it's what we're looking for here is actually saying if we can't find a semicolon, I misspoke earlier, if we can't find a semicolon, just go to the end of, set a index of the very end of that cookie. So we're going to assume that this is the last value in the cookie. And then, so now that we know that we've got both the starting index and the ending index, then we can return document.cookie, and we're going to use a built-in called substring. It's a built-in JavaScript method. Type it right. And it expects the starting index of the string that it wants and the ending index, and it's going to create a substring just like it says from the document.cookie. And so all that work we've done so far is so that we can say I want a substring that starts at this index, C start, and ends at this index of C end. Fairly straightforward. And then that's going to return the value. So if this was actually working, then we would be able to say GetCookie test, and if we assign that to a variable such as then cookie is going to equal Andrew now. It's going to have a value of Andrew. And that's basically all we need to know. So we did a whole lot of work on GetCookie, and all we really were trying to do is to retrieve that value out of a string. And so we had to do some searching throughout the string. We got the index, of the characters in a string, and then grabbed a substring based on the starting index and the ending index. And that's all we need to know. So cookies are useful because, as you read in the article, that sometimes we need to have information that's stored locally, about a particular browser or about a person's, use patterns on a browser, but we also need to send that information back to the server so it has access to it to make decisions as well. And cookies come in really handy as far as that go, as long as it's not a lot of information, since we have that 4 kilobyte limit. You should remember never to store anything secure in a cookie, since it can be very easily, just as we saw, you can look them up pretty easily, and malicious software can read those as well. So nothing secure in them, but if you do need to pass information, they come in handy. And that's it.